Setting up proportions. The student will estimate and find solutions to application problems involving percents and other proportional relationships, such as similarity and rates. Here are the vocabulary words you'll need to know for this unit. Equivalent means having the same value or equal. A proportion is an equation which states that two ratios are equivalent. An example would be 1 over 2 is equal to 4 over 8. That would be a proportion, showing that 1 over 2 is equal to 4 over 8. And finally, a cross product. A cross product is the product of two numbers on the diagonal when comparing two ratios. So if we use the example above, 1/2 equals 4 over 8, you'll notice that when you multiply 2 times 4, you get 8, and when you multiply 1 times 8, you get 8. And so we often use cross products to solve proportions if we don't know one of the numbers. Let's look at an example of setting up a proportion and how it would be solved. In Mr. McKee's class, the ratio of students who own a dog to the total number of students is 16 to 24. Based on this information, set up the proportion and equation to find how many students I can predict to have a dog out of 500 students. So we'll always start with a given ratio, and here our given ratio is 16 to 24. So we have 16 to 24. And we need to know what each of these numbers represent. Now we know that 16 represents students who own a dog. So for short, we'll just call those dog. And then we have to the total number of students. So we'll put total. Now we know that those really represent students with a dog and total students. So when we go to set up our equivalent ratio, we'll keep in mind that on top we have students who have a dog, and on bottom we have total students. One of these is given to us and one we're looking for. We're trying to find how many students I can predict to have a dog. So this is the unknown. And then it says out of 500 students. So 500 would be my total students. And then I don't know how many have a dog. I'm trying to find out. And when there's a value that we don't know, we can place a variable in its place. And so here we will call that x. Now, as we learned in the previous slide, two equal ratios make a proportion. So we have our proportion here. And in a proportion, the cross products are equal, which means 24 times x would be equal to 16 times 500. So I can make an equation to solve this. 24 times x will equal 16 times 500. So we've learned not only how to set up a proportion, but how to set it up to solve it. We will not solve the proportions today. We will simply set up the proportions and the equations in order to solve them. Here's another example. Euros are a currency used in several European countries. On one day in October 2005, you could exchange $3 for about 2.5 euros. How many dollars would you have needed for 8 euros? We'll start out with a ratio. The given ratio is that you could exchange $3, so I've got 3, and this is in dollars, for 2.5 euros. So I'm going to set up an equivalent ratio, keeping dollars on top and euros on bottom. So the question is, how many dollars? That's where I'll put my unknown. So I'll use X for dollars, and then remember euros go on the bottom. So for the 8 euros, now place it under the X. Now, I can set it up to solve it. Because my cross products are equal, I'll take 2.5 times X, and I know that that will equal 8 times 3. This is now set up to solve. Remember, we won't worry about solving it today, we're only setting them up. This example is a little bit tricky. I'd like for you to write down the problem and then see if you can solve it correctly. See if you can set it up correctly, set up the proportion, and then set it up to solve it on your own. So go ahead and pause the video, and then you can check and see how you've done. Okay, there was a piece of extra information here, which was 8 ounces. That might have tricked you. That information is not needed because we're basing the information on how many juice boxes you get in a pack. And so the quantity is the important information here, along with the cost. You can find those key pieces of information in the question. It says, how much would an 18 pack of juice boxes cost if its price is proportionate? So we know that how many come in a pack is important, as well as how much is important. And so those are our two categories. We have dollars and quantity. So it's $5.40 for a 12 pack, and that would be equal to the cost per an 18 pack, because it says it's proportionate. So now, to set up our equation, we would have 12 times X is equal to 18 times $5.40. Here's another one for you to try. Beeswax used in making candles is produced by honeybees. The honeybees produce 7 pounds of honey for each pound of wax they produce. How many pounds of honey is produced if there are 145 pounds of beeswax? Try to set this one up on your own. So pause the video, set it up, and then check and see how you did. If we focus on the question, we're asked how many pounds of honey is produced if there are 145 pounds of beeswax. So I know I'm trying to find out how many pounds of honey, and that information will be based on how many pounds of beeswax. In this case, there are 145 pounds of beeswax. So beeswax goes on the bottom, and on the top I will have honey. Which piece of information is easiest to find? The honey is. It says that there are 7 pounds of honey. For how many pounds of beeswax? It says for each pound of beeswax. How many pounds would that be? Well, if it's 7 pounds of honey for each pound of wax they produce, then we know that it is for 1 pound. And now we're ready to set up our equation. So we have 1 times x, and we know that we don't need to write 1x. We would just write x, because 1 times anything is just the other number. So we have x equals 7 times 145. And that would give us the piece of information we're looking for. How many pounds of honey? Now here's our final example. A certain shade of paint is made by mixing 5 parts blue paint with 2 parts white paint. To get the correct shade, how many quarts of white paint should be mixed with 8.5 quarts of blue paint? Set this one up on your own and then check and see if you did it correctly, so go ahead and pause. Looking at the question, we know we're looking for how much white paint is needed to mix with 8.5 quarts of blue paint. So we know we're looking for white, so we have an X on top with white, and on bottom with blue we have 8.5. Now which one goes on top or bottom is not important as long as you're consistent. So let's find the given information to go along with that. We have 2 parts. Sorry about that, I got the wrong color. We have 2 parts white paint. And how many parts of blue paint go along with that? We are told 5 parts of blue paint go with 2 parts of white paint. And so we'll put the 5 on bottom. And now we're ready to set up our equation. So we have 5 times x will equal 2 times 8.5. This will conclude our lesson on setting up proportions.